Hi Year 10, this is the fourth in a series of 5 lessons that I'm doing on the topic of logarithms. In this video we're going to look at solving equations by using logs. So let's summarise what we've learnt so far. In the first video we looked at defining logarithms and log form and index form. Then in the second video we looked at log laws and the change of base rule. And then in the third video we looked at log graphs. So let's start with exponential equations. Now, prior to learning about logarithms, our only method was to use guess and check, which means that we had to guess a value for x, check how close it was, and then adjust our guess. Now, looking at that equation there, 3 to the power of x is equal to 17, we know that x is somewhere between 2 and 3 because 3 squared is 9 and 3 cubed is 27. So let's make our first guess 2.5. Now we're going to substitute that 2.5 back into x. So we're going to go 3 to the power of 2.5 and it's 15.6, so it's a little bit low. So our next guess is going to be 2.6. Let's try that. So 3 to the power of 2.6 gives us 17.4 and it's just over 17. So if we just want one decimal place, we've pretty much solved it. X is approximately equal to 2.6. But that's a pretty frustrating method to use for a lot of reasons. If you start too far away from the actual answer, you're going to be there a long time. Also, if you want a number of decimal places, that makes it difficult. Using logs is much, much easier and much more accurate as well. So what we do is take logs of both sides. We can choose any base, but obviously we want to choose either base 10 or base e so that we can use our calculator. So, providing we do the same thing to both sides, we haven't changed the equation. So I've got log base 10 of 3 to the power of x is equal to log base 10 of 17. Now you've seen this a number of times now. Here we've got the third log law, so this x can come out the front. So that's equal to x multiplied by log base 10 of 3 is equal to log base 10 of 17. Divide both sides by log base 10 of 3, and it's pretty much the change of base rule, isn't it? And putting it in the calculator, we get 2.578901923. See how many decimal places we get? Approximately equal to 2.58. So this one's slightly more difficult, but it's not too bad. Okay, so rather than guessing and checking, we're going to take logs of both sides. Let's do log base e this time. So it's just ln. So ln of 5 to the power of 2x minus 1 is equal to ln 67. Now this whole index here, 2x minus 1, can come out the front. Be careful to put that in brackets because there's more than one term. Okay, divide both sides by ln 5. And now we're going to work this out. I'm going to keep a couple of decimal places so I don't lose accuracy. So 2.613. Okay, normal equation now to solve. Add 1 to both sides. 2x is equal to 3.613 and then finally divide by 2. And at this point, I'm going to abbreviate to 2 decimal places. So x is approximately equal to 1.81. Let's do one more before we move on. Solve 9 to the power of x is equal to 0.55. Now the curious thing about this question is, if we were using guess and check, we wouldn't even know where to begin. Think about it. 9 to the power of 1 is 9. 9 squared is 81. It's way outside what we're looking for. In fact, x is negative in this question. But even though it's difficult by guess and check, it is really, really, really easy by logs. So let's take logs of both sides. We'll do log base 10. On the left-hand side, we've got our third log law. This x can come down the front. And it's no longer an index. Divide both sides by log 9. And we get log 0.55 divided by log 9, which is negative 0.272. See how easy that was? Now, as well as solving exponential equations using logarithms, there are also various forms a log equation can take. So have a look at these. We're going to solve these over the next 4 slides. So we're going to have log base 2 of x is equal to 5. We could have the pronumeral here where the base is, or we can have a series of logs that are either added or subtracted. They might be equal to a log or not equal to a log. Here's the first one. This is an easy one. We've just got to turn this around into index form. So this is 2 to the power of 5 equals x. And so x is equal to 2 to the power of 5, which is 32. Here's the second one. solve log base A of 15 equals 4.6. Again, we're going to turn this into index form. So I'm going to get A to the power of 4.6 is equal to 15. This one's not quite as easy as the last one, where we had the pronumeral as the argument. Here we've got to get rid of a power of 4.6. Now think of a simpler case. If this was A squared, we would do the square root over here. So what's the opposite operation of a power of 4.6? You could do the 4.6th root of 15, but it's better in index form. So we want to do 15 to the power of 1 over 4.6. Putting that in the calculator, we get 1.802 approximately. So here we've got a log equation that's got several terms. Now we're going to have to use our log laws to solve this. The first thing to check is if the bases are the same, which they are. So when I add logs that have the same base, I multiply the arguments. So this is equal to log of 2 outside of brackets x plus 1 is equal to log 3. Now because I've got log of something equals log of something, the somethings have to be equal. So this has now been reduced to a fairly simple equation. I can either expand through the brackets on the left-hand side or divide both sides by 2. Let's expand through the brackets. Now I'm going to subtract 2 from both sides. 2x is equal to 1, and our answer is x is equal to a half. Okay, last one. It's really similar to the last one, except that we don't have log on this side. But we're going to do the same thing. We're going to join these together. So because the base is the same, I'm going to get log of 2 outside of brackets x plus 1. Now, I can't just get rid of the log here because there's no corresponding log on this side, but I can turn this into index form. So remember, this is base 10, so 10 cubed equals 2 outside of brackets x plus 1. And again, it's been reduced to a fairly simple equation. So this is 1,000, and then that's going to be equal to 2x plus 2. Okay, taking our 2 over, I get 2x is equal to 998, and so x is equal to 499. So that brings us to the end of this lesson. In our final lesson on logarithms, we're going to look at the applications of logs in real life, and there are a lot of them. And so hopefully that'll bring the whole topic together for you.